Students of Estes Park High School have the privilege to be building their very own radio telescope. We call the Bobcat Engineered Radio Telescope BERT for short. This has been made possible by the generosity of the Toshiba America Foundation, the Masonic Lodge, Estes Valley Astronomical Society, and the Estes Park Memorial Observatory.
Hello, welcome to the BERT room. I'm here to tell you the progress that we've made on BERT. So up in our cabinets here house most of our stuff that we have received. Here we have most of our soldering stuff. In this drawer, in this cabinet, we have most of our components and pieces, especially our chassis for the receiver. And our last one houses the styrofoam that we need for the feed horn, and it houses the pieces for our LNA.
Here we have our rotor. It rotates 360 degrees on a horizontal plane both directions and 90 degrees on a vertical plane both directions.
Hello, this is our portion where we'll be talking about our anti-static preparedness. So, first of all, we've been storing many of our things, like for the LNA that can't have a static charge, in these pink anti-static bags with the labels. It prevents mostly the amplifiers from getting shocked and us having to buy new ones once they get ruined. As well as slightly larger versions of the bags and the packing material that they're in as well. The pink tends to be a color of anti-static. This is our K2R spray. It's a anti-static spray that was originally designed for clothing, but we found out has really good use spraying on our counter to prevent it from shocking things.
Yeah, absolutely.
These are our wristbands that we have connected to our grounded anti-static rod. And what you do is you just merely wear these wristbands and it will prevent you from creating a new static charge by grounding you to the electrical circuit.
Hello. I'm going to talk about how we organized everything. So we took our static pieces, the pieces that can't be touched by static, and labeled them in these bags. Here you can see the inspection records, so make sure they're not damaged in any way. We also have the labeled actual piece with its serial number and what it is as a whole. We have this for all our pieces that are in the receiver and the LNA. Anything that has to do with static that would destroy it is in one of those bags. Then we have our POs and all these, the parts list, all of our POs, that what we ordered. Then we have our volunteers, make sure we have all our volunteers and people who just want to be here. And then we have our supply orders. And then we have our receipts, which comes in very handy. In this corner of our room, we have our computer for researching anything BERT from the pole to the receiver. We have a file folder in our file cabinet that holds both our POs, our parts list, our volunteer sheets, our supply and order, and our receipts for everything related BERT. In here we also keep our engineering notebook, which in our engineering notebook we record everything there is to know about what we've done that day on the actual BERT telescope. In this corner we also keep our binders, which are full of diagrams and information and models about the actual BERT telescope itself, so we have something to go off of.
So this houses most of our parts and tells us what we need to do in order to build the LNA, the receiver, and even the feed horn.
Well, there's all the files you've got on it. So I think we'll just call this 111. How's that?
Here you see the weldings that were done by fellow student Nick Hoff and David White, who is a volunteer who's been helping us out. It's a 3-inch pipe welded inside of a 4-inch pipe. They have a little bar stock at the end because that's the only thing that would fit the motor. They actually had to mill the bar stocks themselves, and they had to make another component in order to get it down from the 4-inch size down to the size of the bar stock.
Here you see the concrete being laid out for BERT. It is being laid out by Mr. Johnson, father of one of our fellow students. The hole was actually dug by Mr. Dave Colson, who is our school's Director of Transportation and Maintenance Services. The hole is 6 feet down and about 4 feet across. The form inside was built by David White in order for the concrete to be perfectly square, no edges, so no one trips on it. Thus concludes the first video progress report on BERT.